Hello and welcome to the Analysis Mason podcast. My name is Christopher Baugh. I am a partner at Analysis Mason, and also I'm delighted to be the head of space research for the company. So today we're going to be talking on a very important topic on the podcast, which is government military demand for commercial satcom, but really taking a step down on that, which is integrating that capacity in a secure way with proper service orchestration of what militaries actually need and where that's headed. So today I'm delighted to have one of my colleagues, Luke Wyles, an analyst with us, and also one of the heads of our government and defense research, who'll be speaking on the topic. So Luke, welcome to the podcast.
Hi, Chris. It's great to be speaking with you.
Excellent. So let's jump right in. Now, we know, and I think the market generally knows, that commercial capacity is vital to military entities, including the U.S. government, allied government, everyone around the world. Commercial capacity is critical. Can you talk a little bit about maybe a very brief history lesson, this rising dependency, and how we see this? Is this a short-term trend? Is this something you see persistent, and how this is changing?
Right, sure. Well, certainly governments have been using commercial operators' capacity for quite a long time. That's been traditionally in the geo market. Biggest players like Inmarsat and their competitors who have supported these kind of services. But really the acceleration that we've seen has been closely tied to the expansion of LEO constellations, Starlink, OneWeb, and upcoming Amazon LEO, all these that have really impacted the commercial market and been having a corollary impact in the government market as well. But the sort of entry into the government market was definitely accelerated by a sort of sudden surge in demand and sudden sort of application really around the Ukraine conflict. I'm sure guests will be familiar with the rise in demand there. And so we've seen LEO come to the fore on the battlefield in Ukraine, and it's seen a really short-term acceleration. The service profile, the procurement profile is definitely going to evolve, but the demand for LEO capability is only going to increase. And it really can't be served by just purely sovereign projects. We'll certainly touch on ones like PWSA, Iris Squared. It's going to be served by commercial players as well.
Interesting. So if I would just to kind of paraphrase a bit, so this demand has been there, but the advent of LEO and Starlink and Starshield and everything out there, and then onwards, and Ukraine obviously has just taken the curve upwards, would you say, in terms of utilization, obviously revenue impact, et cetera. We're kind of in that inflection point of commercial capacity, sort of constellation satellite usage for the military entity.
Yeah, certainly. And to just sort of show the acceleration and its impact, the Commercial Satellite Communications Office which accounts for about 85% of the US spending on commercial capacity. That's projecting in 2024, 2025 to grant about $1.7 billion in new contracts. These won't necessarily will be for that given year. Sort of given year consumption is about $1 billion currently, maybe for the USD or the US DoD, but it's going to accelerate quite rapidly through the expansion of these kind of programs.
Okay. So if we take the premise that this is rapidly growing faster, more utilization, more demand, more need, it's the willingness of the entities themselves to use it. So governments, are they using it? How are they using it? Are they willing to rely on satellite communications? Is this for troop welfare, or are we looking more for critical contested communications? What are they actually using it for? What types of missions potentially? And maybe how is that changing, given that there is so much more capacity coming?
Sure. Well, traditionally, governments have trusted their most mission-critical communications to their sovereign networks, like wideband global satcom and Skynet for the UK. And that is probably expected to continue. Really, the increase in government demand has been on a sort of more frontline connectivity. And we've seen commercial really come in, sure, initially for some troop welfare, crew welfare, but increasingly just from a sort of catering perspective, it's come in as the sort of frontline communications option in, say, Ukraine. Now, that's not come flawlessly. There have been electronic warfare attacks, spoofing, things which have interfered with the satellite services on the ground because they're not quite scoped as military-grade protected services. They are actually quite coupled with, say, the Starlink commercial network. And so it's not come without its challenges. And in fact, there is a real challenge for commercial players to be able to assure to governments that their capacity can be trusted in the most mission-sensitive, most contested environments. Now, that's an evolving playing field because the nature of electronic warfare and cybersecurity is their threats and their responses are evolving all the time. But it's become a priority for governments to want to have some more direct control over commercial assets and to be able to orchestrate their commercial capacities in a sort of combined service portfolio, to be able to orchestrate, which just means to sort of manage end to end in an automated way, the capacity at their disposal and have a kind of hierarchy of how trusted and resilient, reliable the networks will be. So yeah, that's kind of the approach, and I'm sure we'll get more into it as we inspect some of the specific case studies.
Yeah, that's a great lead in actually, Luke, because my next question really became, we have the premise, demand is there, they're using it more in an integrated way, and there may be prioritization of traffic based on how comfortable or not they are with commercial versus protected. Let's take that next layer down, which is impact. And in practice, if militaries use more and more commercial capacity, most in LEO, how does that impact capacity, terminals, network management when they're working in this hybrid, protected plus commercial and everything in between way? How does that impact, I say that almost under the ground, management terminals capacity?
Sure. Well, yeah, I think it's very important we touch on terminals, even if we're quite concerned with the software, the orchestration side. The terminals are going to provide the end user with the flexibility to swap between different commercial networks or even sovereign networks, military-owned networks. So there's definitely a real push within government RFPs, within military SATCOM, to have terminals that can have software-defined radio and swap between different operator-compatible modems. So one example is the L3 Harris Razor terminals. That's rapidly adaptable, standards compliant open radio. It's essentially a multi-waveform platform to allow the terminals to swap between the likes of OneWeb and then other commercial networks, other KU networks, or really anything else which the antenna is able to read. So sort of push for multi-orbit. We hear a lot of buzz about multi-orbit within the SATCOM world. Really, a lot of the push is coming from government players, partly because they want to orchestrate across multiple networks and they want the benefits of sort of different parameters of GEO versus LEO. But yeah, so that's about it for the terminal end. You want a software-defined modem, adjustable antenna, and those are being produced by the likes of L3 Harris, or another example is Allspace. They have a tightly orchestrated sort of Starlink, and then also GeoMeo KA. That comes with quite a cost. There's certainly a premium, but it's governments that are willing to pay premium for the most cutting-edge capabilities. Then on the sort of network side, that's probably where there's more work to be done, certainly because a lot of the sort of permissions and priority access controls are all contracted individually. And so you see at the sort of alliance level, several efforts to create a cohesive shared pooling portfolio. So one example is in the EU, they have the Gov SATCOM program that's being developed to pool various commercial capacities that each of the EU players sort of have access to, as well as their own sovereign satellites, like say the French Syracuse system. And this GovSatcom program is meant to be sort of forward-looking so that it's going to be compatible in future with the IRIS² constellation coming at sort of the end of this decade. So these kind of things are taking time at the orchestration level, but they're in development in the EU and sort of elsewhere.
It sounds as if there's been good development. A lot, would you say? Maybe I'm jumping too far. A lot of work to be done, really, on that sort of integration orchestration piece. I mean, would you say still early days or a bit more positive?
It's early-ish days. I mean, to take another example, in the US, the DoD, they have an architectural pilot for something called the Hybrid Space Architecture, HSA. It's a kind of, I think, quite similar idea to the GovSatcom program, and that they want an initial operational communications layer in 2026. So there's certainly activity and some energy behind these kind of policies, quite near-term timeframes. But there is certainly a lot of difficulties or hang-ups that remain to be addressed and perhaps won't even be addressed by these initial deployments. The sort of key issues are around the fact that in a crisis, authority over commercial assets is really blurred. Can governments really rely on private companies when their decisions can be influenced by business considerations or, by other governments that they hold contracts with? Yeah, as I was mentioning, the control at the moment is often really quite contractual. It's not so much operational, where the government has a direct service arm and control over the satellites in operation.
Interesting.
So yeah, it's a little bit more complicated than maybe some of these programs would like to present outwardly. It's certainly one of the key approaches that we keep hearing coming up again and again is in zero trust architecture. It's an essential approach now, where when different devices, commercial or government-owned devices, are interfacing, they need to essentially continuously assume that up-to-date authentication is required, continuous authentication is required, because any device it thinks it's in contact with could actually be being spoofed by a sort of enemy device copying its frequencies.
Okay, so the complexities, it almost makes your head explode thinking about how much needs to go into this and the lines blurring through all of it, whether it's commercial, protected comms, everything downstream. security overlaying it all. I'm going to throw another variable in this, which is alliances, multinational frameworks, sort of this, it's not so binary anymore where government, one X buys this and they operate alone. There are many alliances and working together arrangements. How does that impact all of this? Is this just another, again, makes the problem compound, or are there ways that this actually may solve some challenges easier because you have multiple entities working towards a common goal?
Yeah, well, on paper, I would agree that it is. It's attractive. It's potentially more viable to pool assets between allied countries, and they'd see a local benefit, or they each see a discrete benefit in using their allies' assets when they're not contested. But I suppose, yeah, the issue comes down to how much do you trust your allies? How much do you want to have potentially, sharing on your own sovereign assets, sharing on capacity you've purchased and procured? It does add a lot of complexity in the procurement end. And that's before you even get to the notion of having allied blocks within allied blocks. I just mentioned the EU Gov Satcom program, but that's one which would be operating within the wider NATO Commercial Space Strategy. So there's got to be some sort of additional layer of contracted sharing that is agreed upon at the highest level, sort of in NATO in this example. So I think the sort of more allies you want to involve, the more layers of allegiance you want to orchestrate up above, the more time it's going to take. I think that the NATO Commercial Space Strategy is going to be markedly slower to deploy than, say, the Skynet 6 equivalent. That's the UK equivalent, just because it's so many nations rather than just the one.
Right. So great on paper, but again, when you have lots of parties, it just makes a more complex arrangements. Everyone has their own priorities, so it's an interesting challenge. I like it on paper, like you said, but it does increase the complexities. But I want to go back to something you mentioned, zero trust. I'm thinking about military entities, government entities in general. The governance and control is so critical. It's why they buy their own protected systems. They maintain it all. It's all for them. And you mentioned zero trust. Architecturally, to address these concerns, is that it guaranteeing that high level of security, transparency, visibility, all of this in orchestra? Is that the secret sauce to all of this, or what is it? What do you?
Yeah, that's certainly a key component of it. It's not the sort of be all end all. I mean, I think another strong element to touch on that sort of goes hand in hand with zero trust architecture is having devices and space segment that are waveform agile and can alter their cryptography. So that's building on what I was talking about with the terminals earlier, needing to be software defined and modem swappable. Part of that is to be able to run different waveforms, whether that's swapping over to a sovereign military waveform that's protected and used just by certain allies within the bloc, or if it's looking a bit more future, rather looking a bit more towards the future, you'd be needing to adapt waveform to avoid different sort of electronic warfare or spoofing environments. So the idea of zero trust architecture, you definitely want that to be supported by user devices and satellites that can swap to a different encryption, to a different waveform, and use that to avoid detection and to avoid themselves being deceived by spoofed enemy devices.
Okay, so really that flexibility becomes absolutely vital, like really intense flexibility, it sounds like. So last question, Luke, really this is the dollars or pounds or euros or whatever, so currency, and thinking where the investments are going, because this pattern of commercial integration is so prevalent and is increasing all the time. How is that shifting priorities for when militaries build out their network? Is orchestration the key element to focus on? We know a lot, SpaceX, Amazon, everyone's building a lot of LEO capacity, but from is orchestration the element that you'll see more investment coming into? Are there other areas? How is it shifting the priorities in this segment specifically?
Yeah, I think it is, for medium and smaller nations, going to shift the priority towards orchestration. I think overall this drive to integrate commercial capacity is partly born of the fact that constellations are inherently global, and if you're not a big enough country, it's not very cost effective to have a constellation of your own. And even if you do have a constellation of your own, you need to land the data in different countries. And so they're inherently collaborative. You inherently are going to want to tap into allies, want to tap into commercial systems. And so for a medium-sized country, let's take the UK, for example, they've, for the Skynet 6 program, really prioritized this orchestration element. They've got a company called Babcock running a consortium of, or rather integrating capacity from a consortium of European operators like SES. And so there you're seeing really the priorities in that sovereign network program coming in from controlling commercial networks. And I think it's going to be quite the same for other similarly positioned nations where they've historically maybe had geo, and perhaps they'll continue to have geo satellites, but they can't meet all the demands of the modern battlefield. And so they'll want to tap into LEO, they'll want to run multi-orbit. And it's really quite impossible to envision every significant military power in the world having their own multi-orbit constellation. So really for sort of medium and below, outside of maybe the sort of top 5 to 10 biggest spenders, you wouldn't ever really expect them to have a constellation of their own. And the priority is really going to be on orchestration.
That's interesting. We've authored some articles on that very topic, which is because sovereignty being such a prevalent theme throughout the space industry today and governments wanting to do more in space, to not take that leap, to put a global constellation in place when so much capacity is not over your territory. So, and what that impacts. So great insights here, Luke. I want to thank you. This is a topic that we could go on for hours and hours. The complexities are extreme. We'd love to engage with our audience more. So if you have questions, feel free to get in touch. There is more on this content on this topic on the Analysis Mason website. This is covered within our Defense and Civil Space program. This is covered within our ground segment program and some others. So by all means, have a listen, connect with us. We'd love to hear your questions. And first of all, thanks, Luke. And to automatically receive future episodes of the Analysis Mason podcast, please subscribe on our website. Thank you for listening.